Hello there. All right, so what I would like to do is show you how to do your calculations for probabilities for normal distributions in StatCrunch. All right, so here we have, the question says we have event X. It follows the model. The N says it's a normal distribution. The 90, remember that is our mu. And then, so that's your population mean. And then the 4 is your sigma, population standard deviation. So we're going to go over to StatCrunch. How do we calculate the probability if we have a z-score smaller than -1.2? So if you were to draw this out, normal distribution, the mean is in the center at 90 with a standard deviation of 4. So I'm just subtracting 4 and adding 4, just going out 3 standard deviations. That's enough. We know the curve goes on indefinitely, but that'll be enough to answer our questions. So we know that at the mean, the z-score is 0, and then 1, 2, and 3 standard deviations away, and then -1 z-score, again, standard deviations to the left. All right, so therefore, we want a z-score that's smaller than -1.2. So we are going to, let's draw that in, already in at -1.2, so somewhere over here. So we're interested in the probability of this shaded region. Okay, so off we go to StatCrunch. As soon as I can get it to come up. So over to StatCrunch. Oh, come on, give me a break. All right, so in StatCrunch here, be able to see, let me make sure that I'm sharing the, right, you guys can't see my StatCrunch, so let me make sure that I get you to see what you need to see. I'll switch that screen and move it over here. All right, so remember we were interested in having a z-score less than -1.2. It was since it's a z-score, we are interested in standard normals, right? So it's a standard normal distribution. That's why I wrote down all of the z-scores here. All right, so -1.2. A standard normal distribution has a mean of 0 and a standard deviation of 1 once you convert those values to z-scores. So therefore, we enter that information in here, mean of, oh, be nice if I told you, how did I get here? So let's walk through that process. I apologize. So I went to stat, calculators, it's getting stuck here, then normal. Okay, all right, so enter is already there for now. 0 for the mean, 1 for standard deviation. Once you enter that in, it automatically knows that you're converting to a z-score. Okay, and you're not using x values. So I'm saying that because this x is not going to change to a z, right? And since we were interested in a z-score that was less than -1.2, so we want to make sure that this sign does say less than, and we're going to enter -1.2 here. And once you compute, you see that the curve shows you exactly what I drew up here in green, and it gives you the probability of approximately 12% once you convert that, right? So if the question says, hey, give me the probability rounded to the 2 decimal places, then you'll say 0.12. But if the question says, what is the probability and you're going to round the percent to decimal places. So if I'm rounding this, I'm rounding the percent. So remember, to get percent, I got to move the decimal 2 places to the right. And then if we're rounding this, the percent to decimals, then that would be 11.51%. So once again, if the question says round 2 decimals, then your answer is 0.12. If it says round the percent 2 decimals, for example, then that's 11.51%. Okay. All right. So that's how we're going to calculate probabilities given z-scores. So let's go back. I'm going to have to stop sharing this and then go back to the other screen and get the next problem. All right, so we got the answer there. It was, I'll say 11 point, oh, I forgot the answer myself. I think it was it 51%? All right, now it says, we're going to calculate the probability if it has data values between 87 and 91. Now that's not in z-scores, that's x values. So these are my x values here and z-scores here. So if I'm interested in between 87, it's always good to draw a visual representation. And I know that's a little bit closer to 86, but all right, so there you go. All right, between 87 and 91. So we're looking at this small probability or shaded region of the graph. So let's go and take a look at how to answer this problem. Okay, so once again, we're switching over to StatCrunch. You're going to work this in the same function as we just did. Just once again, I'll go over those steps again. Stat, calculators, oops, and then normal. All right, so the question said between 87 and 91. And these were in X values. So because it's in X value, you have to enter the actual mean, which was 90, and you have to enter the actual standard deviation, which was 4, as given in the problem. So being that I'm interested in between 2 numbers, let's press between, come over here. So we want between 87 and 91 and compute. So again, it gives you the correct curve that we had already drawn out, and your probability is approximately 37%. All right, so what about the next problem that we have on our list? So we would like to calculate the probability. Again, we're still using the same information here, normal distribution, 90 and 4 mean and standard deviation. But this time we want data values greater than 96. So again, we're still staying in X. So if I want greater than 96%, right? So in StatCrunch, I would keep the X values in. And because I want greater than 96, I want to go to standard because I don't want the between. But I would change this, that X values have to be greater than 96. And there you go. So we would say that's about 6.68%, or you can say approximately 7%. I think. All right, so this next one, we're going to work it backwards. So what happens when you are given your data values and you want to know what's the probability? Okay, so it says, what data value must one have to separate the top 20% from the bottom 80%? So you are looking for X. All right, so if I'm reading this curve, we're always going to read it left to right. So if, let's say, this is 0% through 100%, then the bottom 80 and the top 20, I would say, you know, somewhere here. This is my bottom 80%. And then over here is my top 20%. And the question is saying, what is that data value? What is your X? Okay. So the data value, when you're looking for the data value, given the probabilities, you work it backwards. This is when you want to use inverse norm if you're dealing with your calculators. And so let's see, what does that look like over in StatCrunch? All right, so in StatCrunch, I'm still working from this same screen. But remember that this, when you hit calculate, you plug in your X values and you hit calculate, it gives you your probabilities here. Well, you were given your probability already. Let me draw that out for you again. We're looking for what separates the bottom 80% and the top 20%. So therefore, since you have been given a probability, top 20%, for example, so I can come here, I'm looking for X. So because I'm looking for X, do not go to a standard normal, all right? You just want a normal distribution. So you plug in your information, the mean, the standard deviation, and let's go less than, and you can work this either way. You can say, okay, my shaded region is 80. I'm so sorry. Oh gosh, I'm working the wrong problem. If we want the shaded region of the 80, you see that that 80 is to the left of X, so that's less than. So that 80 represents the probability. So if you plug in 80 in the probability space and hit compute, there's my mind again. I have to plug in 0.8 because it has to, remember, probability has to be between 0 and 1. We learned that in chapter 5. So 0.8. All right, and there we go. That tells us that our X value has to be, we'll say 93.4, for example. Okay, now you could have worked the problem out with the 20, but the 20 is greater than X. So if I plug in 0.2 here for 20%, you see that you get the exact same answer. So it's completely up to you, but you just got to make sure you change your signs. I would, whatever way you start doing it, just keep doing it that way. If you always read it less than, then stick with less than. And when you see those words percentile, percentiles always read to the left. So therefore you would enter less than. All right, let's do one more thing. What if I wanted the z-score and not the X value? So if I want the z-score, yes, you can find the X and then go use the z-score formula, but why do all of that? If you want the z-score, then remember that's standard normal distribution. So that means the mean is 0 and sigma is 1. And so if I want the z-score for this same problem, let's read to the left. So I'm going to plug in 80% or 0.8. And then if I compute, it now gives me a z-score. Okay, once again, like I told you earlier, that X is not going to change to a Z. We know it's a Z because we're in standard normal, where mu is 0, sigma is 1. So I know that this value is a z-score, okay, of 0.84. All right, so I hope that was very helpful. If not, if you have more questions, please feel free to join me in the Zoom lessons, or well, not Zoom lesson, but my Zoom office hours in the morning. Or don't forget that the Learning Commons also offers the statistics drop in the afternoon, I think on Tuesdays or Wednesdays in the morning. I think it's Wednesday. Take a look at my homepage. I put it all on there. All right. Y'all have a wonderful day, and best wishes on chapter 6.